Okay. Is my screen is visible to all of you?
Yes, sir.
Okay, fine, thank you. So, just a moment. Just a minute. So actually, this is the week two. Okay, welcome all of you. So we'll just going to start. What is the week two review? Okay, what is there in the course? So in the course, actually, it covers actually the Laplace transformation. Okay, the Laplace transformation, why we require Laplace transformation, what is its importance of Laplace transformation. So uh, the difference between time domain signal and frequency domain signal, how you convert time domain signal to frequency domain, what is the advantages of that? Okay, then that can be possible by using Laplace transformation. Okay, so what are the various advantages of Laplace transformation, then various properties of Laplace transformation, then what is inverse Laplace transformation and its properties, then one major part they have covered here actually the convolution. Okay, so convolution how helps us solving the problems in Laplace domain. Also basics, introduction to transfer function and block diagram. So transfer function and its properties. So they are the major portion that is covered in the week two. So here I'm going to start with some of the basic uh, like assignment session. Okay, I'll go through some of the questions. Okay, that will help you to solve your assignment too. So if you have any doubt and during the session, you can interrupt me and ask me. Okay. So based on these topics, what is I mentioned here, I will solve some of the problems. So let's go to the first problem. Uh, now, here the first question is that is related to convolution. Okay. So it is given that two signals are given x1 to and x2 t. Okay, and x1t is given e to the power minus 2t u of t, and x2t is e to the minus 3t u of t. Okay, so here it is given, and one output is defined in terms of your inputs. Okay, this is the output is given in terms of input. Now the star mark represents the convolution operator. Okay, then what is the Laplace transformation of y of t? Okay, so what is the Laplace transformation of y of t?
Sir,
Yeah,
excuse me.
yeah, Guru Mohan, yeah, can.
Sir, screen is not visible, sir. Please, could you maximize it? Because whatever the problem you have shown is not at all
Okay, okay,
readable,
okay,
sir.
sure, sure. So
Visible.
now it's fine, I think. Okay,
Okay, sir. Okay. Now it's okay.
okay,
Okay, sir. Right, right. Thank you.
yeah, sure. So, how to solve this question? What is the idea to solve this question? So, first of all, that you have to understand what is meant by a convolution. Okay, so I'll tell you some of the major techniques to solve this question, not only by Laplace transformation, but the basic way of solving convolution problem. So what is my convolution? When two signals are given, let's say x1t and another signal is x2t, and this is a convolution operator, then we'll get some output y of t, okay, in time domain. Okay, so generally basically when the structures are cascaded like two functions, two or signals are connected by some cascading structure, then you need to find out the output in terms of input. Then in that case actually convolution helps you to find out this. But what is the definition of convolution? Suppose I'm giving a y of t is x1 t x2 t, then can you tell me what is the formula of y of t in terms of convolution feature? Anybody?
X1 is X2 is, sir.
That is in Laplace domain. I'm just asking you in time domain. Anybody? Let's say y of t equal to, I just have written it, x1t convolution of x2t. So, so what is the output? Here you can represent that. Just I'm writing the steps, you just follow it. Okay. So y of t is generally written as an integration of, okay, minus infinity to infinity, and this x1t is now become some, because it is under integration, so we have to change the variable. Let's say x1 tau, I am saying tau. Then see x2, this becomes t minus tau d tau. This is actually the general definition of convolution. Okay, if two signals are convoluted, then you can need to find out these steps. So how to do that? Suppose here, suppose it is given x1 t e to minus t u of t and x2 t e to minus 3 u of t. So in time domain also it is very easy to solve the question. No need to find out the Laplace domain. But as you are reading this chapter as Laplace transformation, so you need to find out Laplace transformation. So that in that case, y of s is given as x1s multiplication of x2s. So you need to find out the Laplace transformation of this one and simple this one. So here is x1s, here is x2s. Now you need to multiply these two signal, then find out the resultant signal and take the inverse transformation to find out y of t. Okay, this is the Laplace transformation. First step. Second step is inverse Laplace transformation, and the third step is you need to find out your y of t. So suppose I'm first solving this problem using Laplace transformation, but I'll tell you various shortcuts how to solve this question in time domain. Okay. So now suppose what is the Laplace transformation of first one x1t? This will be 1 by s plus 2, right? And this will be 1 by s plus 3. So this will be 1 by s plus 2 into s plus 3 is your y of s. Just to take the inverse Laplace transformation and you'll find out your y of t. You got my point? Everyone?
Yes, sir. Yes, sir. Yes, yes.
but but this is not actually, this is the way you can solve, but sometimes actually the problem will happen. Suppose the signals will be some complex, like very critical questions, not easy like e to the minus 2t u of t. In some cases actually finding the Laplace transformation also tedious, it will take a lot of time consuming. But I just wanted to help you that how we can find out the Laplace transform, sorry, convolution in time domain. Okay, so let's do that. Okay, just let me do that. But here actually your y of t is something different. Okay, you need to find out this one. So uh, so this is not the answer, I'm just giving this one is y of s. This is something different. This is x1s and x2s, but you need to find out the Laplace transformation of x1 t minus 2. T minus 2 Laplace transformation is how much? 1 by s plus 2 into e to the power minus 2s, right? This is the first part. And second part is similarly, you take a minus common. What is the Laplace transformation of x2 minus t plus 3? You just do like that. You take minus common here and the signal will be like this. Okay, this is the signal. Now what you do, first to forget about the minus. Okay, suppose assume that this signal will be x2 t minus 3. Then what is the Laplace transformation? E to the power minus 3s, then x2s. Okay, your x2s is this one, 1 by s plus 3. Now what you do, now whatever the answer is coming, then you come here x2 minus t. What is the Laplace transformation of this one? Anybody? What is the Laplace transformation of this one? So this is the property, x of at equal to Laplace transformation is 1 by mod a x of s by a. Okay, in that case it is x2 of minus t, means a become minus 1 here. Okay, your a equal to minus 1, so it gives you 1 by mod a, this will be, so 1, this will be x divided by minus s. So whatever your x2s is given, this one is your x2s, just put in place of s minus s. So your answer should be how much? E to the power 3s x2 of minus s. And your x2 is how much? 1 by s plus 3. So this will be e to the power 3s into 1 by, 3 minuses, just the reverse. So I think everyone is clear at this point. What I did, how I did it. Any doubt?
Okay, sir.
Okay. So now let's understand what is convolution. Okay. Let's understand what is convolution. So what you did, suppose I'm giving a signal like this. I'm just drawing a ramp signal. Yeah, this is the signal. Let's say -2 to 2, and here amplitude is, let's say, whatever you take 4, and here this signal is, let's say, x1t. Another signal is, you try to understand what I'm doing, then you will get the feel of convolution. Then let's say this is your x2t, and and let's say this is from 2 and this is 4. This will be 0, this amplitude is 1. Okay. Now I'm asking you to find out y of t, which is x1t convolution with x2t. So how you solve this question? Just to remember the formula. What is the formula I told you? Integration of minus infinity to infinity x of tau, then x2, x1 here, then here is x2, t minus tau d tau. So what you did first, whatever the signal is given, just change that variable here first. So what I did here, this one is x1t is given. Next step, what I do, just change the variable. The change the variable means nothing will happen. This will be 2, this will be -2, and the ampli height is 4, and here this one is now x1 tau. Similarly, the second signal will be becomes, this will be 2 to 4, and here the height is 1, and this signal is now x2 tau. Just change the variable. Then what you do, in the second signal, whatever the given, you first find out x of minus tau, because inside I don't want x of tau, I want x of minus tau, means x2 of minus tau. So what you did, whatever the signal, x of tau becomes x of minus tau when you change the signal and mirror the signal in the respect of y-axis. So whatever the signal is from 2 to 4, just take the mirror image of that signal here. So it will be from -4 to -2, and height is 1. This is now your x2 of minus tau. Everyone got this point?
Yes, sir.
Now what is the next step? You just see the first part x1 tau, we are not going to change anything, because in that formula x1 tau is fixed, but your x2 of t minus tau is required. Now we arrived at x2 of tau, but sorry, this is minus tau, but we need to add one variable, that is t. Let's add this step here, adding t. Okay, when you do that, this is very careful step. This x's become x2 of t minus tau. Let's add it, how it will be. Now the signal will be -4, -2, height is 1, but you are adding t everywhere. Okay, this axis is now tau, this is minus tau axis, this is tau axis, positive tau axis, but you are adding a variable t. So when you are adding a variable t, let's at every point you add that variable. Okay, so I'm adding every point that variable. Now what you have to do, you have to just, because then you have x1 tau multiplied with x2 of t minus tau. So the x2 of t minus tau you get, x1 tau now you get multiplied. When multiplication means what? The common portion will comes into picture. What is the common portion? You now check it here. Let's say the signal is I'm doing like this. Let's say this one is -2 to 2, and amplitude is 4, whatever is given. And here this signal, whatever the signal, another plane left hand side, let's say this side is 1. This is a signal, and this variable is -4 plus tau, sorry, 4 plus t, and -2 plus t. Now whatever the common region is coming here, okay, so this one is the common region in this case. But in sometimes what will happen, we don't know this variable t, we don't know this variable t. This variable t may be positive, may be negative, may be 0. So sometimes this is one case. This one is case one. Another case, what will happen? The t value is, suppose it is large. Suppose it is plus. Let's say t is 7. If t is 7, then this value will be minus 2 plus 7 is 5, and minus 4 plus t, 7 I am putting, so 3. So now this variable is coming from 3 to 5. 3 to 5 means this, whatever the box I have written, this rectangle is now lies from 3 to 5. 3 to 5 means it will be somewhere here. If it is greater than some value, let's say that t equal to 7, then it is outside of your x1t and x2t. There is no common region. So obviously there is no common region means your answer would be multiplication is 0. So you need to find out at what region it lies. Okay. Now you understand this point, case 1 and case 2. What is the difference between case 1 and case 2?
Sir, please explain case one, sir.
Okay, let me do here actually. That is little clumsy. Uh, let's see, this one is the first one, minus 2 and 2 x1 tau is fixed, right? Right, sir? This one is fixed. I'm not changing this, right? Now x1 tau is fixed. What is your x2 t minus tau? X2 t minus tau is this one. This one. Okay. Now I'm drawing that on that slide. This one is your minus 2 minus 4 plus t and minus 2 plus t. This is your x2 of t minus tau. Now at this point you are clear, sir, how I arrive these two curve.
Oh, okay, sir. Okay, sir. Those two graphs are okay, sir.
Now let's say sir, case 1. What is case 1? Case 1 means you have to now, because in the integration sign these two signals are multiplied. So when you multiply these two signals, I'm just doing multiplication. Multiplication means when two signals will be multiplied, actually the common region will be considered. So now you just, case 1, you just merge that two signals. Let's say this is my first signal, minus 2 to 2, and in one case, let's say the signal I'm just drawing here, let's say this is my signal, minus 4 plus t, and here is minus 2 plus t, these points. Now here is a small region of overlapping. Okay, so if this signal is like this, then this is a small region of overlapping. Then what is the answer? Answer will be, at this point, whatever the amplitude of x1 tau, because this amplitude is given to you 4. At this point, whatever the amplitude, that amplitude into, and at this signal amplitude is always 1. This one is amplitude is 1, but the integration sign is now become minus 2 to minus 2 plus t and d tau. This is the first case. You need to find out the answer. Case 2, sometimes what will happen, this signal is fixed. I am not changing that signal. Sometimes what will happen, this t value, assume that it is greater than some value. This t value is greater than, let's say 4. Let's say t equal to 4. When t equal to 4 you put here, then the signal will be from 0, because minus 4 plus 4 is 0, and here minus 2 plus 2, 4 minus 2 is 2. So the signal is now from 0 to 2. The signal is from 0 to 2 means this is my amplitude 1. So this is the signal. Now the signal is now here. The overlapping area is now here. So now you have to integrate these two signals from here to here, whatever the amplitude, find out, and here the amplitude. Here you need to find out the slope of that signal. Are you getting, sir, or not getting? Or it's little bit tougher for you?
Sir, minus 2 to integral limits are minus 2 to minus 2 plus t. Then how
Right.
did you get that 1 is 1 into 1, sir?
Sir, it is just the height. You just need to check the height. Height of the signal is 1. And whatever the height is here, I don't say that is 1. Whatever you need to find out the height of that one. It's not
Okay,
1.
sir.
Okay.
Okay, sir.
Let me give a simple example. You may actually Just I have just give a simple example to you, sir, to make you
Okay,
better
sir. Okay.
understand. Let me change the color actually. Actually, this is actually the best process to solve the question. Just actually it is because I have taken a complex example, that's why you are confused. Let's say give an example. Let's say it's your x1t and your x2t is something u of t minus 2. Okay, sir. Now you solve this question by using convolution. So what you do, sir? First, your what is the formula? x1 tau, x2 t minus tau d tau. This is the minus infinity. Now what you do is that you know that this signal I can draw. The first signal is like this. Height is 1. This is up to infinity, so it will be 0 somewhere. So this will becomes my x1 tau. Right, sir?
Okay, sir. Okay.
U of t minus 2, can you draw that signal, sir? U of t minus 2. It will start from 2 and will go to infinity. The height is 1, right? You got, sir, this U of t minus 2?
Yes, sir. Yes, sir. Both the
Yeah.
values.
So now this is your x2 tau, sir. Now you change to minus tau. Because in that formula we need x2 minus tau. So minus tau means this will go from minus 2 to infinity. Like this, sir. Now define for you.
Yes, sir. Yes. Okay.
Now you are adding some t here. See that formula, sir. We are adding some t. Let's say I am adding some t here. So now the signal will be something t minus 2 and height is 1, right? Up to this point you clear, sir? Because at every point you need to add t, right?
Sir, but it depends upon the value of t.
Right, I'm
Suppose
saying
that
that.
t,
Yeah, it depends on the value of t. Let's say t is anything I don't know, sir, whether it is positive, 0 or negative. But you are adding t. So
yes, sir, yes.
So that becomes like this. Now you just multiply these two signals. Whenever multiply these two signals, let's say like this. So this one is the first signal. The second signal is something like this. This height is 1. Second height is also 1. This is t minus 2. This height is 1. Now sir, you just see. If your t minus, this value is 0. If your t minus 2, first case 1. If your t minus 2 is less than 0, sir. If your t minus 2 is less than 0, means any point here you take less than 0, is there any common region which exists? No. Your t minus 2 points that is less than 0, is there any common region?
Sir, no.
No. If there is no common region, then obviously your multiplication value is 0, so your y of t equal to 0, the first case. Now let's say case 2. Let's say, assume that this t minus 2 means you can t minus less than 0 for y to 0 is means for every this value your output equal to 0. Now if you take the second case, let's say your t minus 2 is greater than 0. Greater than 0 means how the convolution will be? This is your first signal. This is, let's say, your t minus 2. Now what is the common region is exists, right? I am saying, sir, t minus 2 is greater than 0. Let's say this t minus 2 point is on the right hand side. Now there is a common region exists or not, sir?
Yes, it's from 0 to t minus 2.
Yeah. So the integration limit is 0 to t minus 2. What is your first signal? First signal is e to the power minus 3t, means minus 3 tau, because already you have changed the variable x1 tau. So, and the second signal is amplitude is 1. This height is 1 and d tau. Right, sir? You need to solve and to find the answer.
Okay, sir. Okay.
So this is the way you have to do the convolution, sir. This is in time domain. This is the just simple steps you need to. But once you solve many questions, then you will be familiar. In one step also you can find out the answer. But Laplace transformation, okay. But in some cases, when the signal is very complex, then when you're feeling tedious to solve the Laplace transformation, then you have to find the convolution like this. Got my point, sir?
Okay, sir. Sir, please keep the slide, sir, so that we will copy it.
Sorry, sir.
Please keep the slide, sir. 1 minute.
Yeah. Okay. Okay.
Yes, sir.
Yeah. Actually, we have actually 2 hours time, so I am just wanted to go in detail to make you understand. If you understand this, then I am just giving another simple example, sir. You just try to solve that, okay? So it's better to solve that question by yourself. Wherever you have faced a problem, then just tell me. So let's say I'm just defining one x1t like this. Let's say everything is 1, and your y of t, let's say, is given u of t. U of t means 1 up to infinity. Now this is your x2t. So suppose that this question will come in any competitive exam, then how I solve this question in one step, in just one step. I know, because you know that this is your x2 tau. No need to change the variable because you know how to change the variable. Just so can you just do the last step? Last step means, can you get understand? I'm doing the last steps for you. 0 to 1, it is fixed. Nothing. I'm changing this signal. This one is now my x1 tau, and x2 minus tau, then adding t. Minus tau means here somewhere I'm adding t, sir. When I'm adding t, let's say this t is coming on the right hand side, so it will be t. Are you getting my second point, sir?
Sir, yes, yes, yes.
X2 t minus tau, because x, this one is x2 of minus tau, so I'm just adding a t value. You got my point?
Yes,
Now
sir.
you have to just play. Let's say case 1. I just try. Let's case 1 means suppose t greater than 0. What I am seeing in the screen. If t greater than 0, then what is my overlapping area? The overlapping area is this region. So in that region, two signal are exist. One is the my fast signal. This up to this high. This signal is a ramp signal. You are need to find out the just the slope of that signal. Okay, y equal to mx. The equation of that line, and so y of t equal to this signal, okay. Let's say x1 tau, you need to find out the slope of that signal, and here 0 to t, this second signal amplitude is height is 1, so you just multiply 1 into d tau. You got my point, sir?
Yes, sir, yes, yes.
And x1 tau is nothing but just the slope of this line. Slope of this line is y equal to mx, so this will be simple tau into 1 d tau, integration from 0 to t. To solve this, you will find. In second case, let's say, sir, your t value is less than 0. If t value is less than 0, then there is no overlap, y of t equal to 0. Right, sir?
It's 0, sir.
Yeah. Let's say another case. Another case will be also exist in here, because sometimes this t value is more such that you will cross 1 like this. If this is my first signal, and the second signal is be something like this. Here t will comes. It is greater than 1 sometimes. All possibility you need to check. Suppose your t greater than 1. Then what is your output, sir? Then the overlapping signal will be the whole signal here and this signal. What is that value?
That's only one triangle, sir. That's
Yeah, but here this is x1 tau. This is only tau, right, sir?
yes, sir.
And second one is height 1 and multiplication. But here the limit will be set from 0 to 1, right? Not 0 to t.
Yes, sir. Yes.
Yeah, the overlapping areas. So in this case, you need to find out the answer. You
Okay,
got my
sir.
point,
Thank you.
sir? Okay.
Thank you, sir. Thank you.
So this is the basic our convolution. Okay, how you need to find out from the definition of convolution, sir. No need to find out Laplace transformation. Just you need to find out from definition. Next come to the second question, the inverse Laplace transformation of one signal. Inverse Laplace transformation actually you need to have some properties of Laplace transformation. So you need to have also some properties of inverse Laplace transformation. So this signal can be written as in partial fraction form. Okay, partial fraction, because the denominator actually it is s square plus 2s plus 1. So I can write this as s plus 3 divided by s plus 1 whole square. So I can split into something a divided by s plus 1 and b divided by s plus 1 whole square. So so any inverse Laplace transformation can be solved mostly by partial fractions. If you solve this equation and you find out a and b, then you need to solve and find out the inverse Laplace transform. This is a common, just I've just taken for the sake of convenience actually. Okay, so some of the question you need to solve, right? Some properties of Laplace transformation, properties of inverse Laplace transformation. So it's very simple question. So you just try to solve. Can you tell me what is a value and b value? This is your total signal. What is the value of a?
A is equal to 1, sir.
A equal to 1. Okay. What is b?
B is equal to 2, sir.
B equal to 2. Okay. So just putting that value a divided by s plus 1 and b equal to 2 divided by s plus 1 whole square. You know what is the inverse transformation of this one? Because you know that e to the power a t Laplace transformation is 1 by s minus a. E to the power minus a t Laplace transformation is 1 by s plus a. So from here 1 by s plus 1 is there. So plus is there. So e to the power minus t e of t. Similarly here. So 1 by s plus 1. Okay. So here actually square term is there. So t e to the power at Laplace transformation minus a Laplace transformation is how much? Just to have multiply square, right? So this will be s plus a whole square. So if you take the inverse Laplace transformation, this will be 2 times of 1t will come and e to the power minus t. Okay. So this is the answer, I think. So this is the practice, okay, just for you. So this is the partial transform. There is nothing hard and fast rule how you solve this question. This is a common sense question. I am moving towards my third question. It's not. I don't want to waste my time here. So I just wanted to make you learn something. That's why my question number 3 is very important for you. This question number 3 is saying that compute the Laplace transformation of a signal which is given in the form. So can anybody tell me how to write this f of t in terms of u of t and something r of t? R of t is the ramp signal. Sir, have you sir know this part, or I'll start from the basic so that you can write this equation by yourself, means in the screen, so that I can start. You give a hint, not a hint. I'll tell you the basic procedure how to from a graph how to write the equation. Can I start from that, or you know this approach so that you can write by yourself? I just wanted to
Please
know.
tell from. Yeah, this is not covered in lecture, sir. That's why.
I got it, sir. I got it. Someone wants to join. No. Okay. Let me start from the basic, okay? Because sometimes actually these are very important in GATE or any competitive exams. Or this is a, let me let me give an equation to you, sir. Let's say a simple equation. This one is 1 minus 1, this one is 1, this is 1. So this is signal f. Sir, for this f of t, can you write the equation? F of t is how much?
So it's u of minus t minus u of t, sir.
Okay, sir. I think
U of t minus 1.
okay. Let me explain, sir, how I'm writing this equation. Sir, writing these type of equations are very easy if you understand how I'm writing. Sir, this line is minus infinity. This line is infinity. So actually, what is there? One person is standing here and is coming like this, and suddenly at minus one, its values goes to one, and after that, it will be like this, right? Just to imagine, sir, one person is starting from minus infinity, and minus one is suddenly increases its value to one, and it is up to infinity. Another at one at this value, another person what he is trying to do, he is trying to reduce its amplitude to again zero, and at this point one another person is there which pulling your leg such that you now becomes from 1 to 0, here from 0 to 1. So there two person is sitting, one person is at minus 1, another person at 1. You are now coming here in this fashion, but one person is pushing away, means pushing your head off such that you can rise to an amplitude of 1. But at this person, when your height is 1, you are moving up to infinity, but you don't know that another person is sitting at 1, he's pulling your leg so that you again becomes 1 to 0. Then at that time, whatever the graph will be there, then that signal will be like this. You understand this concept, sir?
Yes, sir. Yes, yes.
So now you just apply this concept and write this equation. So you know that, sir, u of t
Yes, sir.
signal is nothing but this is your u of t. U of t means you are initially you are starting at zero line. Again, you are suddenly at 0 point. Your amplitude is 1 and you are continuous up to infinity. The same concept I am applying, sir. But you are not moving your height to 1 at 0. You are moving your height to minus at minus 1. So the equation is become now u of t plus 1. Right, sir? This part I'm writing. So if your height is increased at 0 point, then it will be u of t. But here your height is increased at minus 1 value, sir. 1 you are lagging, sorry, you are leading 0 by 1. So that's why u of t plus 1, right, sir?
Sir, okay. Then we have to subtract one from another.
Yeah, you have to just subtract. So u of t plus 1, another time, no, you just see your height is now 0 to 1 increase, sir. Here your height is decreased. That's why you are decreasing by 1. So that's why your height is now become minus 1, right, sir? That's why u of which point? At which point you are coming? This point. Here now you are y of t. Got my point, sir?
Sir, yes, of course.
If you not get, then sir, tell me how this height is 1. Here height is 1 because you are rising from 0 to 1, and here is minus 1 because you are falling from 1 to 0. This is rising slope, this is falling slope, right? Got my point? So can I move away, proceed further? Hello.
Okay, sir. Okay, sir. Okay, sir. You can.
Okay, if you understand this one, now we will try to understand another concepts. Let me Okay. Let's say this one, 0, 1. This height is also 1. So what is the y of t equation, sir? Now this is another concept, sir, because this is not a unit step signal, it is like a ramp signal. So what you do, sir, like that. Let me start. So what you do whenever there is you are seeing a ramp, whenever you are seeing a ramp, write out the slope of that. What is the slope of this line, sir?
1, sir.
1. So you just write the slope here 1. Okay. And here the signal is rising, and this is the ramp signal. So ramp signal is generally represented by R of t. So it is rising. So now, sir, in what situation you are rising? So you have started here, okay, and at 0 point suddenly you are like a projectile motion, means making an angle 45 degree. Okay, you are moving at this point. Now, but you are moving in this direction. Okay, because ramp signal when write R of t is nothing but the signal is up to infinity. This is your R of t signal. Now you can see in the first half from 0 to 1, but at one point you are coming down suddenly. You are not moving. R of t means you are moving up to infinity. So if you write in terms of R of t, you can write that this is your R of t, because at 0 point you need to start. So that's why this is R of t. But at one point, what is happening, sir? At one point you are coming suddenly down. You are moving at a slope of 45 degree. Here, if I assume that it is my reference axis, my 0 axis, I am shifting this x axis to here. Then here this angle also 45 degree. So at 45 degree you are moving, but suddenly you are coming this line, to the this line. So how much change is happening? From 45 to you are coming here, then again from this line to you are coming how this here. So how to write that? So how to write that? First of all, you have already writing 1 into R of t. You are moving up to infinity. But suddenly at one point, what is happening, sir? First, at one point, somebody is pulling to make you match the reference, this reference. So what you do? So you are
Minus of R of t minus 1, sir.
right, minus of R of t minus 1, because why this slope is again 1? Because at what slope 45 degree you are moving, the same slope 45 degree you have to come down, so as that you can match with this line. That's why the slope is again same, minus 1, R of t minus 1. But now you are reaching in this line, in this reference line. From reference line to at one point you need to come here like this. Okay, so what you do, sir? Again u of t minus 1, because again you are coming down by one height. Okay, so for that minus 1, and at which point you are coming? At one point, so u of t minus 1. Are you able to get it, sir?
Yes, sir. Yes.
Yes, sir.
If you understand, then you can solve this question very easily, sir. I will not tell, sir.
1 by s, sir, e to the power minus.
Yeah, just I'm writing. Uh, Someone wants to join, I think. Let me see. Yes, sir. For the first part, you tell me. For this part, yeah, y of t is how much, or f of t is how much? How much, sir?
2 into u of t.
Right? 2 into u of t means that, sir, you are moving in this direction, but suddenly at t point you are coming down.
Yes, sir. Yes, yes. Mine, we have to deduct.
Yeah, how much you have to deduct, sir? You have to deduct what is the height.
minus 4 of u t minus 1
Minus 4 of u of t minus t, right?
t.
Now you are reaching at this point, okay? You are reaching at this point, but you are moving here like this because you are suddenly, this line is become this line. But at this point, someone is making you to go this line, this here, okay? So how you write that? So what is the slope of this line, sir? It is a rising slope, okay? It is a rising slope. What is the slope of this line? Slope means y by x. Change in y by change in x. Change in y is 2,
2 by 2t, sir.
2 by 2t. And but you have to move, okay? So how you will move? R of, write down R of, because it is ramp signal, you have to write R of. And in how you write, how you go, sir? At which point you are moving? T. So it becomes R of t minus t. Got my point?
Yes, sir. Yes, yes.
But is this the final equation?
And at 2t, we have to cut that signal, sir.
Yeah, because now, sir, you are moving up to infinity. But at same slope, you have to come on the x-axis. So you have to subtract. So how much I will subtract? The same slope. Same slope means again 2 by 2t. R of, at which point, sir? 3t point. T minus 3t. Got my point, sir?
Yes, sir.
Any, okay. Then, and just tell me what is the Laplace transformation, because in the question he is asking us to find out the f of s. So what is the Laplace transformation of this one? 2 divided by u of t
2 by
Laplace
s
transformation is s minus 4 u of transformation is s into e to the power minus st plus 2 to cancel, so this will be 1 by t. What is the Laplace transformation of r of t minus t? So r of t minus t, you can write it, sir, like that: t
1
minus
by
t
s square.
into u of t minus t. Okay, t minus t into u of t minus t. So it will become how much, sir? 1 by s square will come because of r, and how much of ramp signal r of t becomes 1 by s square and e to the power minus st. Similarly here 1 by t, 1 by s square into e to the power minus 3st. Is this question is clear?
Yes, sir.
Okay, thank you. So moving towards the next question. Yes, it is a very important question. So initial value theorem and final value theorem also is covered in the week 2. So what is the answer of this one? Using initial value theorem, find the initial value f of 0 for the following function. What is the answer?
Four.
Answer is 4.
Yes, sir.
So first of all, my suggestion is that, sir, when you are applying initial value theorem, first you check that where initial value theorem cannot be applied. And what is the definition of initial value theorem? How will you find out initial value theorem? Let's say f of t is given as del of t plus 3 into e to the power minus t. So first of all, you find out the Laplace transformation. F of s is how much? Del of t Laplace transformation is 1 plus 3 divided by e to the minus t Laplace transformation is s plus 1. Now this is your f of s. What is the initial value theorem is saying? Limit t tends to 0, which becomes limit s tends to infinity, s into f of s. Right, sir? This is the initial value theorem, right?
Yes, sir.
Now,
Yes,
Yes,
sir.
yes.
now you find out the limit of this one. Limit s tends to infinity, s times of f of s is 1 plus 3 divided by s plus 1. If I multiply, I will get s plus 3s divided by s plus 1. And here limit s tends to infinity. So what is the value of this one? Limit s tends to infinity. If I put s equal to infinity, infinity plus 3 into infinity by infinity plus 1. So it will be limit s tends to infinity, infinity plus 1 is infinity, so it will be something 3. Let's infinity get cancelled. So limit infinity plus 3 is infinity. So your answer is infinity. So then what is the answer?
But actually, it is not applicable for, I think, impulse function.
Yes, sir. Actually, don't be sure, sir. What is the, how you say 4? I don't know. But actually, first of all, if you are using solving this question by formula, means by using Laplace transformation, then you see that your limit does not exist because your limit is an infinity value. So as you at this formula you're putting, you're getting an infinity means limit does not exist. As the limit does not exist, so initial value theorem is not applicable. So the answer will be fourth. Okay. So
Yes,
initial,
sir. Actually, I forget the thing.
yeah,
Thank you,
yeah,
sir.
right, right. So
So,
sometimes,
sir, by
uh,
sir, by seeing, can we tell that, sir, whenever a delta function comes, it's not equable?
yeah, you see, sir, del of t plus eta, del of t plus 3 into eta minus t. So what is a del of t signal? Can you tell me, sir, what is a del of t signal? Del of t means an impulse signal. Impulse is not defined by its amplitude. Its amplitude is infinity, sir. Yes or no? At delta equal to 0 means at t equal to 0, its amplitude is infinite, right?
Yes, sir, yes.
So some infinity plus, if you put, you just put t equal to 0, sir. Because your limit initial value theorem is what? You have to check at t tends to 0. T tends to 0 means, first of all, you have to understand what is impulse function. Impulse function means impulse is defined by some regions like that, and its amplitude is always infinity. And in this region from 0, 0 plus or 0 minus, its amplitude is infinity. So whenever your t tends to 0, its value is coming infinity, and here if you put t tends to 0, this value is 3. So infinity plus 3 is infinity. So this function is infinity. So can't say what is the initial value theorem for this function, you cannot find out because impulse function is there. By looking also you can say that at t tends to 0, del of t is infinity. That's why infinity plus something is infinity. Got my point, sir?
Yes, sir, yes.
Okay. Let's move towards another question. I think I have one final value theorem is there. Okay. So now you just find out what is the final value of this function f of t equal to t into e to the power t, 3 into e to the power t. So it's to join. Same definition, sir. Final value theorem means limit t tends to infinity, f of t, which becomes in Laplace domain, limit s tends to 0, s into f of s. Just
Three.
uh, so if you put here, so it becomes 3. chance to join. Is it fine? I'll solve. Is everybody understand this question? Shall I move?
Okay, sir. Okay.
Okay. But sir, the answer is not 3. Okay.
Yes,
Yes,
sir.
sir,
Since
again,
it is
again, incorrect.
Lysine function,
Yeah.
so answer should not be 3, sir.
Right. Actually, I just told you, sir. Just I'm just checking that again you are applying the formula or not. Because sir,
Yes,
you just
sir.
try to whenever you are applying initial well theorem or final well theorem. First of all, you have to make sure that at what condition you cannot apply this theorem. If also you solve this by using this formula, also you're getting a limiting value which is infinity. And again from if you see cell 3 into e to the power t, e to the power t is something the signal will be start from here like this. E to the power t. It's a rising function. See, the area is unbounded. It is an unstable and unbounded signal. Unstable, unbounded signal. So you cannot find out the limit first. The limit is always infinity. Limit is always infinity. So if you also put in the formula, let's say I'm putting s tends to 0, s times of f of s 3 divided by s minus 1. Okay, if I put limit s tends to 0, s times of f of s 0. So something how much? 3 divided by minus 1. So what is the value?
Value will be 0.
Yeah, value will be 0 means value exists. Okay, so answer many people should choose 0. But actual answer is not applicable because the limit is does not exist. It is unbounded signal. And final value theorem is only applicable for stable and bounded signals. That's why. Okay. So limit is exist, but the signal is unbounded.
Sir,
You're
please could
getting
you explain it, sir? Explain by.
see sir, because this first of all there are some conditions sir before applying initial value theorem, final value theorem. Initial value theorem is applicable only for minimum phase system. In the latter stage of a control system, you'll get able to know that what is a minimum phase system, what is a non-minimum phase system, what is a all phase system. So minimum phase system means actually whenever all the poles and zeros are lies on the left hand plane. Okay, so you have to check that condition first. Secondly, whenever you are applying final value theorem, you need to ensure that final value theorem is only applicable for a stable and bounded signal. So first of all, this signal is an unbounded signal. Unbounded signal means why I'm saying it is an unbounded signal, sir, because if you find out the Laplace transformation of this signal, this will be 3 divided by s minus 1. And you can see this is an open loop transfer function, f of s. I'm not finding out the closed loop. So you can see that one pole is exists at the right hand plane, RHS. So if one pole is exist at the right hand side, so the system is actually a non-minimum phase system, and this is an unstable system. So for an unstable system, you cannot, first of all, you are not able to apply this formula. This formula is not valid. So as this formula is not valid, so finding out whatever the limit is coming, that does not matter. Whether your limit is exist or doesn't exist. First of all, you cannot apply this formula because it's an unbounded signal. So first of all, that point you need to set in your mind that whenever you are seeing a question of initial value of final theorem, you first need to check what is the condition before applying this theorem. So many people should say that okay, because answer is exists, so answer people will choose 0. But actually the answer is cannot find out. So final value theorem is not applicable here. I think
Sir, for specific functions we can check, but for polynomial or for given transfer functions in terms of s, First, we have to check whether it is stable,
Yes, you have
unbounded,
to
or not.
check whether it is stable or not unstable system.
Okay, sir.
You have to check whether, otherwise if you apply then you will coming at a wrong answer, because this formula is not valid. So final value theorem is not valid. Then this formula doesn't exist. Getting my point, sir?
Yes, sir.
Okay, actually this complete I think it will be covered again whenever you will going for RH criterion, because RH criterion is Raut RH criterion. In that case, uh, you will come across these steps how you check the stability of a system. So in that case also, at that time also, initial value theorem and final value theorem again will be covered. So at that time will be better clarified if it is not covered in proper details. So let's move to the next question. So now actually here the question is that you have need to find out the transfer function of a electrical circuit. So how you do that? Transfer function definition is that it's Laplace transformation of output divided by Laplace transformation of input with initial condition is 0. Like, this question actually this is a very famous actually gate question. Actually sometimes you need to find out uh, these type of questions, especially this question. This question is, I think, during my gate time, this is a very famous question. How need to find out the transfer function by using one step or two step? Because if you solve this question, it will take hardly half take one page. But first of all, solve this question. What is your approach? How will you solve this question? Output divided by input. So first of all, you have to write the equation. Okay. Let's say I1. Here is I2. Frame two equations. Then you have to find out one equation in terms of other. Then you have to have a relation between output by input. Uh, each anybody have solved this type of question before?
Yes, sir.
Yeah, because already you
Yes,
know
sir.
how to write this equation minus v in I1 R1 1 by C1, and this I1 minus I2, because here this is common. So dt equal to 0 is the first equation. Second equation you find out in the second loop. R2 I2 plus 1 by C2 I2 dt plus 1 by C1. Here moving in this loop, second loop, so it would be I2 minus I1 dt is equal to 0. Find out the Laplace transformation of these two equations. I think you can solve this. Okay, if I'm going to solve, it will take a half page. Half page. But in these two equations, there is no V naught term is not coming. But you need to find out V naught S by V in S. So you need another equation. Your output voltage V naught is how much? V equal to 1 by C2 I2 dt. So here the second term is nothing but a V naught. So what you do, you have to completely eliminate I1, I2. So there are two equations. I1, I2 is unknown. You have to substitute one in place up other, and you need to find out the Laplace transformation. Yes, ma'am. Are you any problem?
Sir, the answer will be 1 upon s plus 1 to the whole square.
Sorry, ma'am. Just a minute. Let me check actually. Uh, yeah, actually the answer is something like this. I'm just writing your answer because 6 and 7 are related questions. So your answer will be V naught S divided by V S equal to 1 divided by R1 R2 C1 C2 S square plus R1 C1 R1 C2 plus R2 C2 times of S 1 plus 1. This is the answer, ma'am.
Okay, okay, sir.
Actually, just give me a couple of minutes. I just need to find out the shortcut. Let me remind. But ma'am, it is a very famous, sir, it is a very famous actually ladder diagram. Okay, so just remember this answer for your future. Just remember this. Actually, I cannot. How I find out this shortcut method? I'll clarify in the next class. Actually, forgot. R1 up to C2. Because in my when I was reading, actually, just one professor told me how to get the shortcut of this one. Just forgot. Okay, just remember this. It's a very famous. Sometimes what will happen now? Why I'm just telling you this is important because this is a ladder diagram. R1 C1, R2 C2. This is a very famous question. So here is V naught and here is Vn. Sometimes in the question exams they will remove one. Okay, let's say C2 is this part is not there. Only R1 R2 like this. So in that case, you just put C2 equal to 0 in this expression. Whatever the output by input is fine. Suppose C2 is there, and suppose this C1 is not there. Let's say C1 I have removed. Then you just put C1 equal to 0 like that. And suppose R2 is not there, you just put R2 equal to 0. So in this, if you know this formula, then if any circuit is given to you like this T type of ladder network, then you can find out the V naught S by V in S easily. So just remember this formula. This is so for, first of all, the first term is just a multiplication of all the components. So whatever the components R1, C1, R2, C2. And suppose I'll tell you the shortcut in the next class. I'll tell you. And suppose
But
another
one
term is there.
one question, sir.
Yeah.
Suppose C1 is not there, then we can remove C1 in the final transfer
Yeah,
function
you can remove C1. That is the actually advantage of remembering this equation. Suppose another network is there R3 C3, and how you find out? Suppose R4 C4 is there, then you cannot solve this equation and find out 8 equations, and you have to remember solve. It will take 1 hour. So I just forgot sir, the shortcut. I'll tell you next class surely how you. But the fast term, remember that in fast term is always the multiplication of all the components. All the components R1 C1 R2 C2 R3 C4 R4 C4 times of S fourth, because here sir how many times because the order of the equation will depend upon number of energy storage elements. So here The first case only two energy storage element is there, C1, C2. That's why the order will start from S square. But if it is 3 is there, then definitely this will be R1 C1 R2 C2 into R3 C3 into S cube, because there are three energy storage elements. The order will be defined by the number of energy storage elements. So like that, sir. You got my point, what I'm trying to say?
Yes, sir.
Okay,
Yeah.
sir. Okay, sir. Sir, next
Yeah.
class starts with this problem most probably.
Okay, I started scrolling just to make me reminders. Okay. Now, if you know the answer of this one, I have written answer, and then if you put R1 R2 all of is one, then he's asking us that the electrical system has a distinct or negative real roots or something. Okay, so let me solve this one. V naught S by V in S. If I put one, then V naught S by V in S, it becomes 1 divided by everything is 1, so it becomes S square, and S square, because everything is 1, so 1 plus 1 should be 3 times of S, and this is plus 1. Now you solve this question, sir. So if you find out the roots, then just need to find out the roots of this equation. S square plus 3S plus 1 equal to 0, then find out S1 comma S2. Then we'll get some answer from all of it. It is a stable system, right, sir? S square plus, because the inner product is greater than the outer product, right? Yeah. So it's a stable system. So the answer should be, what is the answer, sir? S1, S2. Can anybody tell me which is the correct option?
So option will be, I think, A.
What is the ma'am S1 and S2 get? S1 equal to how much? I'm just solving it.
I have not solved
Like
it
this, you can
completely,
solve
but yeah,
2s
that's what
plus
is.
s plus 1. So it should be 1 divided by s into s plus. No, no. S into s plus 2. No, it cannot be like that. Some complex will come.
Yes, sir.
Minus b minus b plus minus b square 9 minus 4 sc divided by 2 into 1. So this will be minus 3 plus minus root 5 by 2. No, ma'am, means complex is not coming because root 5 is something 2 point something. So minus 3 plus, let's say 2 point, let's say I'm assuming 2.5, approximately I'm saying, by 2. So something negative is coming, right? So one
Yes,
is,
sir.
uh, so negative real roots, okay? Distinct and negative real roots. And these two are distinct, it cannot be same because one is plus, another is minus. So minus 3 plus something, minus 3
Yes, sir.
minus something. Yeah, like that. Let me next go to the next question. Question 8. So wants to join or what? Is this portion is covered, ma'am? What is DC gain of the system in the course? Are you sir following? Is following this question, which I think is covered. I have listened the video. Hello, is me. Are you there? Are you sir following me?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
What is the DC gain of the system? What is meant by DC gain? First, because this is also a famous question. What is a DC gain? DC gain means DC means what? Frequency is zero, sir. Okay. DC gain of the system means frequency is zero. Frequency means A is equal to J omega. Okay. So it means A is equal to 0. You just put omega equal to 0 means frequency is 0. So A is equal to 0. When you put A is equal to 0 in this system, okay, so your G of S is becomes 2 divided by 5. So be zero
To
point 0.4.
5.
So the DC gain of the system is zero point 0.4. Next, for next another question related, question 8 and question 9. Next, question number 9 is saying that is there a system pole located on the right half of S plane for S greater than or equal to 0? So it needs to solve this and tell me that whether the any pole is existing on the right hand side or on the left hand side. So part 9 is saying that you just need to find out how you solve this. So open loop, this is an open loop transfer function. And DC gain of the system always remembers that is very important. Yeah. DC gain of the system you need to find out for the open loop transfer function. And but the question number 2 is saying that is there a system pole located on the right half plane or not? System pole means you need to find out the closed loop transfer function. That's the critical point here. So for question number 9, for it is given that g of s equal to s plus 2 divided by s cube plus 3s square plus 7s plus 5 is an open loop transfer function. You need to find out the closed loop transfer function for a unity feedback system, mostly a unity feedback system. So you just need to s plus 2 become you add here in the denominator. So your closed loop transfer function it becomes s plus 2 divided by s cube plus 3s square plus 7s and s and your 5 plus 2. So 7s plus s is 8s plus 7. So this becomes s plus 2 divided by s cube 3s square plus 8s plus 7. Right. 9. You just need to solve this equation and find out the number of roots. Up to everyone is clear how I find out the closed loop transfer function? If you have any calculator, then you can just put these
Yes, sir.
values and tell me the answers first. I just need to conclude some of the conclusions from this question. That's my important motive. What is S1, what is S2, and what is S3? Three roots. Use the calculator, find out the answer. I don't have calculator here. I just wanted to convey some shortcut how to know that.
Sir, One AC will be 1.1.
This one is 1.1.
Actually, it is in polar form. I have to
Right,
change it in
right.
complex.
Complex number will come.
Yes, sir. Yes, sir.
Yeah.
1.1 with angle 180 degree, and another one will be 2.41 angle 111.88.
Okay, ma'am. Okay.
Change it in complex number.
Okay, means I just wanted to convey that actually. Just my point is that you need to find out by yourself, no problem. Just I just wanted to convey that whether this system is stable or not. By looking at the denominator, can you please confirm that whether the system is stable or not? This is the third order equation. So finding the roots is difficult sometimes in the examination because you don't have time to solve in the calculator. Just by looking, just by looking the denominator, you just tell me that whether the system is stable or not. Because in the denominator, SQ plus 3s square plus 8s plus 7, it is there. This is the denominator. So whether the system is stable, if the system is stable means uh, whether the system is stable means, is there a pole located on the right hand plane? You can find out. A pole is located on the right hand plane means the system is unstable.
Yes,
So
sir.
so now the shortcut actually what the shortcut is that. So remember that these two ma'am are the inner product, and the coefficient of the two outer side is the outer product. Outer product. Okay. So whenever your inner product greater than your outer product, the system is stable. Coefficient I'm saying. So the inner product coefficient is 8 into 3 is 24. Should be greater than outer product is 7 into 1. So 24 is greater than 7. So the system is stable. If your inner product is greater than outer product, the system is stable. And sometimes if the inner product is less than outer product, the system is unstable. Your question might be, if your inner product is equal to your outer product, then the system is critically stable. It is called critically stable system. So in this case, my inner product is greater than outer product. So my system is stable. My system is stable means no poles on the right hand side. All the poles should be in the left hand side. Whether it is complex, that doesn't matter. Okay, a system is like that. Suppose one pole is -1 plus j1 here. Another should be the complex conjugate -1 minus j1. Another is somewhere here. These are the three poles. One is here, another is here. So all are on the left hand side. Whether it is complex, that doesn't matter. But all the poles on the left hand side, the system is stable. You got my point, sir? What I'm trying to convey
Okay, sir.
that by
So
looking,
if any negative sign is in between there, sir, then also we have to take the uh,
no, sir. If a system negative sign is there, then by default the system is unstable. The actually in the denominator, whatever the terms are there, all should be positive for the system to be stable. If anything negative is coming, by default it is an unstable system. No, don't consider that for checking for the step. So that's why in the stability, when you come to RH criterion, in that case, actually the first condition of RH that for system stability is that all the coefficient of the denominator terms will be positive. If it is positive, then it is fine. If it is negative, then the system is unstable, and you want to make a unstable system stable, you are adding some poles or zeros. So that is different concept. So that will you learn step by step. But if a system is stable, then you can observe by this. Stable or not. You got my point?
okay, sir.
Yes, sir.
There is no further questions I prepared. So 9 questions I prepared. So If you have any doubt, then tell me. Otherwise, if any new thing you wanted to learn, otherwise I will experience some of the things that I'm doing here. So first of all, uh, let me clarify your doubts if you have any doubts for week 2 by yourself. So convolution part is everyone is clear, I think, right? How you solve the convolution. I told you two methods. So one you can solve by using Laplace transformation. That's is very fine. And second thing also you can use by looking at by just inspection, that by using the formula you can find out. No need, because why convolution in Laplace transformation is tedious? Why? Because first of all, whatever the signal is given, you find out the Laplace transformation. Then to find out the original signal, you have to take inverse Laplace transformation. So one person should be very carefully apply the formula. Then inverse Laplace transformation always require partial fraction. So it will be time consuming. So I don't prefer to solve the questions in Laplace domain for convolution. You just try to solve it by time domain. If it is okay, otherwise if you are looking that time domain is difficult when uncertain question is coming, then you can go by Laplace. Because Laplace is easy because you just find out the Laplace transformation and multiply and taking inverse Laplace transformation. But the time consuming. That's some time to say.
Please
Anyway,
tell some more examples in convolution, sir, by graphical method.
okay, okay, okay. Yeah, I just yeah asked a very question, sir. Uh, just a second, sir. Just wanted, yeah. Okay, okay. Let me. You will solve, sir. I already told the concept. Okay, let me give some question. U of t, convolution of U of t. These are some standard questions just today. So what is the answer?
It's U of t, sir.
No, U of t, convolution of U of t cannot be U of t, sir. Just you want to check? I'm just going by Laplace domain, just quickly. So 1 by s, multiplication of 1 by s, 1 by s square. You have to take the inverse of 1 by s square is t U of t, right? This is in one step.
It will be ramp.
It is a ramp signal, R of t.
Okay, sir. Okay.
Similarly, just if I say e to the power minus at u of t, convolution of e to the power minus at u of t, then what is the answer, sir? If I want to solve by using, no, I'll tell you by graphical method I am solving, okay? Just if I solving it easily, 1 by s plus a into 1 by s plus a, so it becomes 1 by s plus a whole square. If you take the inverse Laplace transformation, it will be t times of e to the power minus a t, u of t, right, sir?
Yes.
Sir, okay.
So what is your understanding? The understanding is that when this signal convolution with the same signal convolution will be result like this. One t is just multiplied. Here also same. U of t, one t is just multiplied. Let me give another example. Let's say I am just explaining question number one in terms of let's say u of, let's me given graphically. Let's say minus one. This is minus one. This is one. Convolution with same signal, same minus one, one. So what is the answer? Means how graphical it will be.
Oh yeah.
Sorry, ma'am. What is the answer, sir? Sir, hello, sir. Are you there?
Yes, sir. Yes, yes.
Yeah, yeah. Yes, sir. Tell me. Because for you, I am just solving this question.
So far we have to invert it. Then means the same thing comes, and we
Yeah.
have to.
I'll solve these three questions by graphical method. First, just let me solve quickly. Just I want to convey that whenever you are multiplying same signal, what you results. You see, sir. So this signal can be written as like this: t plus one, u of t plus one minus u of t minus one. Right, sir? Convolution of
Correct.
same u of t plus one minus u of t minus one. So what is your understanding from here, sir? If I multiply two u of t signal, I will get r of t signal, right? So can you tell me when this one is first, second, third, fourth? If I multiply it, this is multiplying convolution. So what I will get? U of t is when one is convolution with three. So what you will get, sir? R of, because see u of t same signal. So what you will get? R of t, right, sir?
Yes, sir.
So what is the answer? R of t plus one, right? No,
Yes, sir.
actually, we're
Yes.
not getting actually. No, it is not R of t plus 1. It becomes R of t plus 2. Because I have forgotten the properties. Let me come here. Let's say e of t plus 1 convolution with e of t. Then what is the answer? And here is e of t plus 1 convolution with e of t minus 1. What is the answer? So what is their convolution properties? That's whatever the coefficient here is the coefficient t minus 0. Okay, so if I write the expanding form in your brain, if you if you utilize the signal, then it will be u of t minus 0. So whatever the t is here, you just put everything here. Okay, like this. So it will becomes u of this t minus 0 is coming here. In place of t, you have to just put t minus 0, and then plus 1 is there. So it becomes u of t plus 1. Okay, and u of t and u of convolution, the u of t is not u, it's become r, so it becomes r of t plus 1. Similarly, what you did here, u of, in place of this t, you just put t minus 1, so t minus 1 plus 1, so it becomes how much? Minus 1 cancel, so it becomes r of t, like that. You're getting my point? Let's say u of t plus 2 convolution with u of t plus 3, then what is the answer? R of t plus 5. So whatever this signal, just put here in t. Let's say u of t plus 5 convolution of u of t plus 7, then your answer should be R of t plus 12, like that. You got my point, sir?
I actually didn't, sir. First line. How did you get it, sir? Actually,
So
it's not.
this is a convolution property, sir. Convolution property is that if a signal x of t convolution with y of t plus let's say t plus b, then your answer should be something, let's say z of this t plus b, whatever the signal is now. So you just put in place of t, so it becomes t plus.
But this thing we have not come across in either any of the classes, sir.
But just for the convolution property, sir, now you just remember this. This is
Okay,
a
sir.
convolution property, sir. How this is called shifting, how the shifting of signal will happen.
Okay,
Whatever the
okay,
signal
okay.
is there, and the second you just put that in first in place of t. Got my point, sir?
Okay, sir. Sir, please hold this, sir.
Oh, you just wanted to.
Okay, sir. Okay.
Now just I'm removing. Why I just uh, wanted to solve one or two questions because just try to understand what I'm trying to do here. Let me, sir, the signal is given minus 2 to amplitude is 1 and it is convoluted in the same signal. This x of t is given. Then a question is that y of t equal to convolution of x of t, convolution of with x of t, same signal. Then what is the answer? You can now tell me faster because just write down x of t. X of t is how much, sir? U of
T
t
plus
plus 2 minus u of t minus 2, right, sir?
T minus. Yes, sir. Yes, sir.
You are now multiplying with the same signal, right?
Yes,
So
sir.
another
Yes.
signal I'm writing x of t equal to u of t plus 2 minus u of t minus 2. Now you just multiply it, okay? So your y of t equal to, so this is 1, this is 2, this is 3 and this is 4. So multiplication means 1 should be multiplied with 3. When 1 should be multiplied with 3, it becomes r of t plus 4, sir, right?
Okay, sir. Okay.
Then 1 should be multiplied with 4. So it becomes minus r of t. Then again 2 should be multiplied with 3. That should be r of again t. Right? And the last is become r of t minus 4. Are you following? Just multiply, sir.
Okay, sir. Okay. Okay.
Now you draw this signal. Can you draw this signal, sir? R of t plus 4 minus this become 2 times of r of t. No, just draw the signal from here. Can I draw the signal like this? So here is starting from minus 4, t plus 4 equal to 0. So starting point is minus 4, sir. And it is a ramp signal. It is a ramp signal. It is going up to infinity. But you now see that at t point at 0 position, r of t means at 0 position, someone is pulling it down, right, sir?
Okay, sir. Okay.
It is now coming here, okay? Now again at 0 position, another person is coming it again down by the same slope. So it is now coming here, right? Okay. But again at 4 position, someone is, oh, this is minus minus plus 4, right? So again at 4, someone is, because it is a positive slope is same, so it is again positive. So now this is the final answer. Clear?
Okay, sir. Okay.
So amplitude is 1. So what is the answer? What is the solution you got? That when these type of square wave signals are there of similar amplitude, means you are multiplying the same signal, you will definitely get a triangular signal. You'll just get a triangular signal. But if I change the question, let me change the question. Same signal is there, minus 2 to 1, but it is now convolution with minus 1 to 1. Now tell me, sir, what is the answer? Be fast. This will be u of t plus 2 minus u of t minus 2, right? Convolution with u of t plus 1 minus u of t minus 1, right, sir?
Okay, sir. Okay.
Now just tell me in terms of r of t. So this will become r of t plus 3, right?
Okay, sir. Okay.
Then minus r of t plus 2, t minus 1, you put here t minus 1. So it becomes t plus 1, right? Then third term will be u of t plus 1 here, t plus 1 minus 1. So this is r of t minus 1. And minus minus plus, it becomes r of t minus 3, right? This is the answer.
Okay, sir.
Now you just draw that. Then the starting point should be say minus 3, okay?
Yes, sir. Yes, sir.
First of all, you identify the points. These are the -3 point, this is -1 point, this is 1 point, this is 3 point. Now you just draw. These are ramp signal. Our slope is 1 because coefficient is 1 means slope is 1, so it is going somewhere. Then again at -1 point, someone is pulling down because the slope is negative, -1. So it is going like this up to infinity, but someone is pulling down straight because this same slope it is coming down. Again at t equal to 1 point, this point, another person is pulling it down. Then at 3 point, someone is pushing it off the same slope. So this final signal will be merging with the x-axis, right? Right, sir?
Yes, sir. Yes, yes.
So what is the observation from the last question and this question? The observation is that when two signal having same width, in the previous question the same signal were multiplying, having
Yes,
same width, then you are getting a triangle. But
triangle.
now
Okay.
the different signal you will get a trapezoidal.
Yes, sir. Yes, yes.
That is the observation. By looking, you can say that.
Okay, sir. Thank you.
You try to solve this question by graphically, sir. These are very easy to solve. I mean, it's not difficult that way. Graphically. Anything you wanted to ask more? Because another 10 minutes is there. Just one graphical questions I am doing for you. Let's say that question I told you, e to the power minus t u of t, convolution with same signal, e to the power minus a t u of t. Can you tell me in graphically, sir, the first graph will be like this, right? Amplitude 1. Second one is same signal I'm saying. This is 1. So this is an x of tau. This is your second signal is x1 tau. Let's see it is x2 tau. Now you just reverse that one. If you reverse that one, mirror image with respect to x2 minus tau. Now you have to add t, sir. Whenever you add t, let's say it is shifting towards further. So it is up to infinity. Let's say this point is now t. This is 0. It's up to infinity. It's up to infinity. Now it is clear. This is x2 t
Yes, sir.
minus tau. Now you just multiply these two signals. Now I'm just doing here for you. This is the first signal. This signal. Okay. Now the second signal is something here like this. Now you just need to find out. This is 0. This is t. Now you just find out the area. What is the area, sir? 0 to t, e to the power minus a tau into e to the power minus a tau, d tau.
Yes, sir. Yes.
But this is not a tau, sir. It is t minus tau. A t minus tau. Sorry. This is a t minus tau, sir, right?
Yes, sir. Yes, yes.
Yeah. I can solve, sir. This is very easy way to solve. Okay, I think it is okay for all of you. Try to solve the assignment questions. Okay.
Okay, okay, sir. Thank you, sir. Thank you very much.
But before leaving that, I just wanted to ask you one question, sir. Because here actually in IIT Bombay, actually 2 days back I was just taking a lab of BTech students. So in that actually you were just performing one transformer is there. This is a basic simple question for all of you. One transformer is there. So here we are applying some 230 volt AC single page, and here one load is connected. Just a lamp is connected. Lamp means a bulb. You can take 100 bulb or 60, 100 watt or 60 watt bulb. Okay, sir.
Okay,
Getting
sir.
my
Okay.
points. So here actually what is happening? One student came and he put a tester here. Okay, sir. This is dot polarity here. Dot is here. Let's say it is a 2:1 transformer. So when he put a tester here, so the tester does not glow. So the tester actually does not glow. But when he removed that bulb, now bulb is not there. Now this is a open. Is open. Now he put a tester at this point. Then the tester glow. And obviously this is negative point. The tester does not will glow here because in AC supply actually one is our mains, another each one is neutral. So generally the neutral where you will not find the tester to glow, but in the because that is negative with respect to positive. That's why at this point tester will glow. Here tester will not glow. Tester will not glow. But why that case? Whenever putting a bulb, the tester will not glow. Because this is dot polarity means if it is positive, then this terminal also positive. This is negative. Means tester should glow here.
Yes, sir. Yes, it should.
It should glow. But actually when the load is not there the tester is glow, but when the load is there the tester will not glow. And second question what we observe that when you change the polarity negative and positive you just reverse the supply. In our home sometimes actually what is happening, we are changing the polarity some due to some regions, and suppose the load is refrigerator is connected. So mm, when you change the polarity what is happening, the tester is now glow this side because this is positive. Tester will glow here. Tester does not glow here.
Yes,
Tester
sir.
does not glow.
Yes, sir. Yes.
Okay. But what is happening now? The tester is glowing on both the sides. Here also glowing, here also glowing. Why?
Sir, sir, tester glowing both sides means neutral has cut at some point, sir.
That's the point, sir. We are very curious to know. Actually, we ask some professors also. They are just thinking that how it's happened. It does not. It should not be happened.
Sir, as I'm a practicing engineer, actually, I'm doing in public sector. If tester glowing in both sides means neutral might have cut at some point, so that positive is continued till that point.
But sir, actually, what has happened now? This is a transformer. Actually, in the transformer, there are some knots. Means this is a open-ended. So if this point is negative, this point is positive. We just change the polarity. So here, the tester starts glowing on the body also. Means that the body, the current is flowing. Suddenly, some student will touch accidentally, and connection is just reversed. Then he will get a shock. I don't know what is the answer, but the first answer I understand that whenever you are not connecting a ball, actually, what is happening now? If you do the equivalent circuit of this transformer, this is a 230 volt AC, and this is a highly insulating material, sir. So maybe there is a maybe not. There is actually resistance of this insulating material of mega ohm is exist in series coming into picture of the transformer. So let's say it is some 10 mega ohm. So and whenever you are testing this as a tester, so whatever the voltage here 230 volt, that voltage will be coming up to across this 10 ohm, 10 mega ohm. And tester is having a high means high value of resistance. So that's what the tester is glowing. But when the bulb is you connected, bulb is just 60 watt bulb having some 1 ohm or 5 ohm resistance. You connect in series with that 10 mega ohm. So with respect to that 10 mega ohm, this 1.5 mega ohm or 1 mega ohm is just short circuit. That's why this ground is coming to this ground here. So that's why the tester is not glow because it is just measuring the ground potential because it is behaved as a short circuit that board. And that point is clear, but when the
Sir, tester take observes the voltage, sir. Whether it is connected, any resistance is not a thing, sir. Because the bulb is glowing means you are getting 230 volts or 125 volts. Then tester measures voltage, not that any resistance is connected in between like that, sir. If bulb is glowing means you are giving that 125 or any voltage to that bulb, then voltage should be there. Then tester should glow, sir.
actually say I
And
guess
I am not convincing with what you said.
okay
Because
okay this is a
tester
this
even glows for 50 volts also, sir. 50, 60 volts. is also there, then also
But
tester glows.
tester is glowing, but it just actually we have just tested in the lab. Actually, tester previously, because whenever there is no load, means open load, in that circuit tester is glowing at a means that glow is visible to your eye. But when you connect a bulb of 160 watt, a tester is just dim. It is not visible at open eye. The tester's glowing is not glowing at all. Okay, so I will discuss this in
Okay,
later time.
right, sir. Right. Thank you, sir. Thank you very much.
Okay, okay, sir. Thank you so much, all. Okay,
Thank you, sir.
okay. Thank
Thank
you
you,
so
sir.
much. Yeah, most welcome.
Thank you once again, sir. Once again, thank you.